Hello, this video is a quick tutorial on Venn diagrams and the size of sets. This roughly corresponds to section 1.3 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. But this is not explicitly a problem. This is just something I've noticed a lot of students have run into. It's a little bit of a mind bender to get your brain around, so we're just going to kind of take it slow. Specifically, this video is about what I call the overlap in Venn diagrams. So on my screen here, you're going to see three lovely dots. There's a blue dot, a yellow dot, and a red dot. And we're going to say that these dots live within the universe. And so this big square is typically how you see the universe drawn in finite. And what they mean by universe is this is the total number of things that we've counted. So that's also called U. And so in this case, we're going to say U is 100, and that number doesn't matter. I'm not really going to do math here. I'm just going to talk about the concepts. So let's say that our universe, or the things that we have counted, is fruit. And so we have counted 100 different kinds of fruit. Very exciting, I know. And, we've separated them into the kinds of fruit that are blue, here in the blue circle, the kinds of fruit that are red, here in the red circle, and I don't know how many fruits are yellow. I can only think of one. But here are the fruits that are yellow, here in the yellow circle. And then, so the things outside, and I don't really want to, I'm not going to leave this here forever, but all the stuff out here, all the way around, I'm going to get rid of this later, this is stuff that is neither blue, nor red, nor yellow. So, this is your green fruits right now. This is any fruit that is neither blue, nor red, nor yellow. We're going to go ahead and get rid of that. That was just 4 examples. So why is this important? Well, that would be pretty easy to figure out how many fruits are not blue or red or yellow, because you'd take how many fruits we've counted as blue. Let me do that on the right layer. How many fruits we've counted as blue. Let me do that in the right color too. Wow. Okay, how many fruits we've counted as blue, how many fruits we've counted as red, and how many fruits we've counted as yellow, and we would subtract that from the universe here. And that would be pretty easy, right? We could do that. That's simple mathematics. Everybody who's listening to this, I think, would not have a problem with it. It'd be maybe a little bit of brain work, but it wouldn't be bad. But what if the Venn diagram looked more, well, what if there were fruits that were both red and blue? So let's go ahead and show what that would kind of look like. So, what if there was this overlap here? And so these would be fruits that are both red and blue. So, maybe we'd call them purple. I don't know what you'd want to call them. And so there's this overlap. So all of a sudden, if you counted all the fruits that are blue and all the fruits that are red, and you subtracted them from the universe, these fruits in here would all be counted twice, because there's this overlap. So that's what this section is all about, figuring out this overlap and making sure you only count everything once. And so, this doesn't seem too crazy, I think. It's just a little bit to get your brain around, but what if, even further than this, oops, let's go ahead and select the whole yellow. What if there were fruits that were, blue and yellow, and fruits that were red and yellow? And what about these guys right here in the middle that are blue, red, and yellow? And remember, I'm not really talking about fruits. We're using these colors as just an easy example. But the section in the middle is very interesting, because if you're not careful, you'll count the things that are in here, these little X's, you'd count those things 3 times. And you don't want that. So the big thing to remember, and what I'd like you to take from this video, is these overlaps. And so you've got, in this one you've got 4 sections. You got these 3 where only 2 things overlap, and then you got this one in the middle where 3 things overlap. Those sections are really important, and those are the tricky parts of problems that are about the size of sets. How many things are both blue and red? Okay, so that's the number of things in that little section. How many things are both red and yellow? That's the number of things in that section. And so if you had to find out all the things that are neither blue nor red nor yellow, you'd also have to make sure that you didn't count those sections multiple times. So this has just been a quick talk about sets. play with them, think about them. You don't want to count things twice. That's the thing you want to remember. You want to make sure you only count things once.